Hello friends, welcome to JavaFx 3D tutorial. Now we are starting a new sub-series, and in this sub-series we will learn about JavaFx animations. So in this very first video we will learn a keyframe based animation, and in this example we will create a circle and the circle will move towards the right edge of the screen. After that it will return back to the original position. So that's what we are going to see, and here we will learn what is a keyframe based animation. In keyframe animation, we will perform shape transformation in a continuous manner. In keyframe animation, we will perform shape transformation in a continuous manner. The KeyValye class defines the transformation item and its value. So this is one class that will represent the transformation item as well as its value. So here when we talk about transformation item, the transformation item will be like translate, rotate, scale. All these stuffs are considered as a transformation item. So we need two or more key value. Here we are talking about key value, right? We need two or more key value to be plotted on the animation timeline. Right. So if this is the animation timeline, say tx to ty, we need at least two key value. So this will tell us the animation timeline, and this is one key value and this one is the next key value. So we know that animation will play for a specific time period. Let's state that animation starts here and it is keep on playing and it ends here. So we call this as animation timeline. And we need two or more key value to be plotted on the animation timeline. Say for example, here we can plot one timeline, or say for example here we can plot one key value KV1, and here we can plot one more key value. Let's state this as KV2. Right. So key value class defines transformation item and its value. So transformation item in the sense here we can say for example we can state translate and we will specify a value 1. Then in KV2 we will specify translate and we will specify one more value, say for example translate value 2. Keyframe defines key value. So this is key value class, and keyframe defines the key value at the specified point. So that's keyframe. Keyframe defines key value, this one, at a specified point in time. So when we talk about key value tells you what type of animation. Say for example, if it is rotate, it will tell rotation, then a rotation value, say for example 15-degree rotation. So it can be applied to any shape, but that's what the key value states. Then you can apply this key value on a timeline. Say for example this is 0 and this one is 15 seconds. So key value 1 this one, when it is applied to a specific timeline, we can call that as a keyframe. So keyframe can be defined at multiple places. So this keyframe may change the transformation. So first it may be a translate, then it can be a rotate, and at some point it will be scale. So that's what here we are talking about. Keyframe defines the key value, this key value at a specified point in time. So for keyframe, we will supply the key value and we will also link that with the time value. So this decides what kind of animation to be played between two time slots. So key value and keyframe, if you see, it is linked with the key value as well as a specific time slot. So this one is a duration here, but here we are talking about time slot, at what time the key value needs to be linked. So that's what called keyframe. Once keyframes are ready, a timeline object will be constructed based on the keyframes. So once keyframes are ready, not one, when you define two or more keyframe, then you can define the timeline based on those keyframe. So here we are talking about key value, that's one thing. Then we are talking about keyframe. To construct keyframe, we need key value. Then using the keyframes, we can construct a timeline. So this is the timeline of animation we can call. So if you define timeline here, this is linked to the keyframe. So keyframe defines key value at a specified point in time. So this is a specific time, and let's state that time is going on like this. This is each second tick. So you can pick a specific time stamp using the keyframe, and to the keyframe you can link the key value, and key value tells what kind of translation and the duration. So similarly, you can link the key value with each keyframes. The play method on the timeline. So once timeline is constructed, the play method on the timeline performs the animation defined by the keyframe. So the relationship, if you see, timeline, once you create the timeline, from this timeline you can make a call to play method, and this timeline, if you see, it is constructed based on multiple keyframes. Here I just took two keyframes, and each keyframe is linked to a key value. So this defines the transformation KV2. So once you play the animation, it knows the keyframe, when to start, when to end, and what kind of transformation to apply between these two time frames. So based on this, we will define the timeline based animation. Now let's look at some piece of code. One can use below property of timeline to control the animation. So once timeline is constructed based on keyframe, which is linked to the key value, we can make use of the properties of timeline. Say for example, cycle count. So this tells how many times to play the animation. So if this is the timeline and it plays a particular animation, say for example, the animation is rotating this bar to 360 degree. Let's state that it's a self rotation, it will rotate one full circle about its center. So using the time cycle count, you can tell how many time to play the animation. So if object is rotating and if one cycle is counted as like this, a 360-degree object is rotating, and if we set cycle count as 4, then the same sequence will be played 4 times. So it will make sure that object will get rotated for 4 times. So we define timeline for one sequence, that means for 360-degree rotation. So it will say the rotation 0, rotation 360 based on key value at a different keyframe in the sense from timeline 0 to timeline 10 seconds, one rotation will be completed. And if we set cycle count as 4, then the rotation will be done for 4 times. That means the animation will go for 40 seconds. Auto repeat. So at cycle end, follow the reverse path. So auto repeat. So that means here if we state that if first time if the animation is played in clockwise direction, the auto repeat will do the reverse. That means from 360 it will come back to the 0th degree. So this will be one cycle, and if you say auto reverse, the path will be in the reverse direction and it will end here. So that's what auto repeat. And the auto repeat is counted as one more cycle. Rate. So using this rate, you can increase or decrease the animation speed. So that's one more property on the timeline. Even though you set timeline to, say for example, 10 seconds, by making use of this rate, you can extend this 10 seconds to 30 seconds based on rate, or you can speed up the animation by increasing the rate. So the animation will end in 2 seconds, even though it is 10. So just taking it for example. Here, for this example, and for the first run, what we are doing, we are creating the circle with a gold color, and we set some stroke, black color stroke. Then we create a translate object, and we are relocating this circle to 250 to 150 x, y location. So in the stage we are relocating it. So c1.get transform, add tran1, and after that we are adding this circle. So we learned about a transformation in the previous series. So the circle will be relocated on the stage to x 250 and y 150. So after this we get the translate x property from this circle object, and we call that as tx. So translate x means here we are getting the translation on x direction. So if a circle is created, it can move in x direction, or it can move in y direction, or it can move in z direction as well. Right. So using translate x property, we are just picking this one. That means we can move either in positive or negative direction from its current location using the translate x property. So the same way you can get ty, tz as well. So once we get translate x, we are creating the key value. So this is kv start, and then we are creating kv end. So This requires, in the previous slide we saw that KeyValye requires two entity. One is the what kind of transformation we want to do. Here we specified we want to do a translation. If you want rotation scaling, you can get the relevant property and you can supply that. Here we are supplying the tx property, c1.translatex property. So we have double property and we are setting that here tx and minus 260. Remember, this is the initial location for the translate, but here for the animation start we are specifying it as minus 260. Say for example, if this is the stage, and let's state that 250 is here, and when the circle is initially here, we are moving it towards the left edge for animation start, right? Tx minus 260. So in the negative direction we are moving it from the center. Then KV end, so this will be the end, KeyValue end, we are specifying it as a 260. So we specified the animation location minus 260 to plus 260, right? So we defined our KeyValue start and end location. So KV1, this is a translation, right? KV1 is minus 260 and KV2 is plus 260, right? So we just defined the location. We defined two location and we defined that using the KeyValue. The KeyValue tells us what kind of transformation. The transformation is translate. That means it's a linear movement, and we specified only the start and end. So definitely this is how we specified it. Intermediate location we doesn't specify, we just specified the start as well as end, and it's a translate. After defining the KeyValue, we specify the keyframe using the KeyValue, and if you see here we are linking the KeyValue. This is KeyValue end. And if you see, keyframe links the specific time slot in the time frame. In the previous video we explained that, as well as that will link the KeyValue. So we already created KeyValue and we defined the location, and here we are defining the keyframe. And if you see here, the keyframe is defined as duration 0. So in the timeline, this specific point is 0, and we are linking that with a KeyValue 1. So this is actually the keyframe 1 that denotes timeline 0, and at timeline 0 the object is located at minus 260 in x direction. In y it is 150. That's the initial translation we gave, right? All right. Similarly, for keyframe end, we can say in timeline, let's state that this is the keyframe end. We will call it as KF2. And this keyframe end links to our second KeyValue, right? So this one is 3 seconds. So here if you see, we just defined the animation timeline. The animation is timeline between 0 to 3 seconds. So this is 1 second and this is 2 seconds, and animation will play for 3 seconds. And at 0 second, the circle should be at -260, and at the third second, it should be in the 260 on y direction, get past 0 and reach 260 on the other end, right? So that's what we defined. Keyframe start and keyframe end. So this keyframe tells the location in the time scale 0 to 3 seconds, and key value tells what is the object transformation during these two time frames. So keyframe, you can, even for easy remembrance, you can tell it as a time frame. So this is the time frame, the keyframe is linked, and the keyframe which is linked to the translation value, key value, right? Now we create the timeline based on these two keyframe which we created, kf start, kf end. If you see, the constructor what we are doing is timeline. So it's a timeline based animation, right? Timeline, and we are giving the keyframe 1 and keyframe 2. That means KF, keyframe start and end. So the animation will be played between this start and end. So KV start 0 second, this is 3 second. That means the total duration of the animation is 3 second without any change in the rate, and it knows what kind of object is involved in the transformation. So we retrieved the transformation for C1 object, right? So this is the shape involved. The shape is circle TX. We extracted it and we gave that TX. That means circle at -260 and circle at +260. At 0 second, it will be at -260, and at third second, it will be at +260. Now, here we are doing the cycle count 3. That means the object will move from here, cycle 1, cycle 2, and cycle 3, right? This is 1 cycle, 2, 3. But here, if you see, we are creating animation for this one only. And using the set cycle count method, we are repeating it for 3 times. Alright, now we are making t1.play, and this will play the animation. Now let's go to the demo and see how to play the animation. Here we will create a new file, copy, and we will do a refactor paste. Keyframe, animation, keyframe animation, and we will do a refactor. So this is from our previous example. We will delete this. So as part of a prerequisite, we talked about creating the JavaFx application. So once you create JavaFx application, in the start method, you can start adding the code. So in the start method, we create the anchor pen first. Then we set the size of the anchor pen using the scene 500, 300. So here we are setting the title as animation keyframe value based, and we are creating the circle. So after creating the circle, we set the stroke. So the circle radius is 20, color is gold color, and outside stroke or the pen color, outline color, we are setting it as black. Then we are creating the transformation for translate, and we are relocating the circle to 250, 150. After that, we are adding that to the stage. So to know where is the initial location, we will run this. So the circle is towards the center of the stage at this time, but when we start the animation, we will relocate it towards the left, and end we will specify here, right? So if you see here, C1 is created. Now we create two key value for the shape location at translate X. It will be towards the left, and key value end is towards the right, plus 260, and we are linking that to the keyframe start and end, and we create the timeline. Here we are setting the cycle count as 3, and we are making the play. Now we will build this once. All right. We can play it. So that's cycle count 1, this is cycle count 2, and this is cycle count 3. That's it. After that, animation play is not happening. And if you want to have more cycle count, you can do that as well. Here, if you see, I'm deleting this and keeping the cycle count as 10. And let me reduce the, this is the duration, right? Now let's rebuild. The circle will move fast, but animation will play for 10 times. Six, and it will stop now, right? Let's go back to 3 and keep cycle count as 3 here as well. You can also use cycle count as infinite, so timeline dot indefinite. In this case, animation will be played forever, it will not stop. I will just run it and wait for 4 times. This is first, second, third, and you can see this is keep on playing, right? It will not stop. So we will close this. Next, you can use the auto reverse property to true. This means we saw that when we are setting cycle count as 3, animation is played from left to right, and that goes for 3 times. But the moment you set auto reverse to true, the yellow circle will get translated in a reverse direction. And let's run the file. This is the first time, second time, and the cycle count 3. It will stop now. So if you see here, auto reverse is happening. So you can also control the animation speed. Here, if you see, animation speed is increased. Why? Because here it is decreased. Now let me run it, and you can see it will move slowly. And since auto reverse is there, it will reverse from there. So it completed 2 cycles, and you can see the play is reduced now using the set rate function. You can also increase the speed as well. Here I'm going to keep 5, and you can see the animation speed will be 5 times. So let me rebuild this once and run the file, and you can see it will be so quick, right? Because we set rate as 5 here. Alright, that's all here in this video. For a quick review, we extract the translate object using the translate property, and using that double property, translate property, we will construct the key value that tells the shape's location. Here tx is linked to C1, so this will tell the shape C1 or circle's initial and end location using the key value start and end. But this tells the object location only. To link that to a time value, we use the keyFrame, and we tell the time slat. And since this time slat information is there, we create the timeline and we play the animation. We also saw what are all the properties you can set to the timeline based animation. That's all here in this video. Thank you for watching. Bye.